Hello and welcome to another video. Today we have mainboards from a single person, multiple ones, and we have a letter. It's quite faint already. But, hi mainboard medic, I sent you a couple of motherboards, mostly MSI. Two Mac B550 Tomahawk motherboards are packed in another box. If you could please repair those Tomahawks, I would be more than happy. Other boards are for you if you don't want them or you want to repair them, let me know. Thanks for everything, best regards. So, these are the two that he was talking about. These were packed separately. And we want to be repairing these two boards and want to focus on them. There are many more in the box that he has sent me, but I haven't even taken a look at all of them. I just took these two out because he said these are the two important ones. And yeah, these are, as far as I can tell, the exactly the same model, a B550 Mac Tomahawk from MSI. And I would want to start with this board right here because I've already spotted something that is wrong on this board. So we're going to see if this video will contain both of them or if these will be separate videos where we repair these boards. So on this B550 board, I already spotted one thing, which is right here. There's a missing coil. So this coil is probably for VPP. For 2.5 volts on the memory side. So without this, many other voltages won't be there. And we will have to check what is up with that. If there's maybe... People remove coils often because there were short circuits or something similar like that. So let's check if we see a short on either side of that coil. So let's get a ground and let's go here, and we don't have a short, and they are also not. Let's go in an actual resistance range to see. So it doesn't appear that we have a short. Let me get a good ground just to be sure that we actually get a reading. But no, it has a really high resistance, huh? Yeah, this seems to have very high resistance. I'm not getting anything on these pads. Yeah, really high resistance. And I'm pretty sure there's more damage in that area. If I'm not mistaken, I can see ripped components and in a similar area to the right here as well. So there's components broken here and I think here. We will have to go on the microscope and investigate that area. So let's get the microscope view in here. So now we can very clearly see that we have ripped components. So this might have been a solder block, but these two and that has been ripped off. Is this capacitor? No, this capacitor is also not attached anymore. So let's continue to see. All of this looks fine. But let's go to the right here. And I can see more ripped components right there. So these two also have to be put back into place. And there might be another one here. So yeah, quite a of components that we are missing right here. But this looks like just a soldering job. Let's see for around the CPU socket if there's anything here. Because this is an area where people like to knock off components as well. Let's look at this is the BIOS chip in this component. No, that's just a little bit of dirt, okay. So this looks fine for now. So it seems like it's just the area for the memory that has gotten a hit. So yeah, we will be needing to go into this area and solder stuff into here. I would want to take this heatsink off of the PCH just so we get some area to work with. And then we will have to go into a board view and check out what we are actually missing. So there's quite a bit of soldering that we need to do. And I want today use a soldering iron that I was given by FNIRSI, the HS02. This is a 100 watts max soldering iron that supports PD, Type C, up to 20 volts, with 5 amps then. And they have provided this for free. And I want to use it in this video and want to see how it performs. I usually use a big station to solder. But I have started with a TS100, which is a small handheld USB-C soldering iron also. And in this case, we also provided with a power brick by them. Let's see, this is a gallium nitride charger. So this is very efficient with 100 watts. And the outputs are, let me see. Yeah, there it is, 20 volts at 5 amps. That is what we want. We want the biggest amount of voltage and amperage to power the soldering iron, so we get the most out of it, which is very cool that this is included by them. As you can see, it is by them as well. And they have also included a quality USB-C cable, which with even a leather strap. That is very fancy, but it is very good. I think this is like silicon or something. It is very flexible, which is very important, so you don't feel the cable too much when holding the soldering iron. So let's get that attached. And you also have a barrel jack to USB-C. So if you want to use a bench power supply, you can also do that. And let's now get the actual soldering iron out of here. As always with FNIRSI, it is very well packaged. And what I especially like is they have a good carrying case for this. So this focuses on portability, which I don't really need because, as I said, I'm using a station. Yeah, this is just quick instructions. This is not important for us. Let's look at the carry case. Get the peel off of here. The carry case looks very fancy, obviously. Very quality, like we used from them. And it has a nice folding hinge. That is great. So the soldering iron, I've seen this thing, and it is quite bulky, which is one thing of it. As you can see, for comparison, it is bulkier, but what I really like is it has a short range for the tips. That is really important. The TS100 that I have has like this long tips that protrude from where you grip and where you have the tip of the soldering iron. It's very important that you have a short length. This will make you a lot more precise. So we have the USB-C input at the back. Let's see, are these? Yeah. These use, I think, does this use the C245 tips? I think it does. So let's see, I have genuine JBC tips here. For example, this one. The right one is the genuine JBC one, and the left one is the one from FNIRSI. And they look to be compatible. Yeah, they are compatible. So the biggest thing is you can use original JBC tips. The JBC tips are really flippin' expensive, but they're worth the money. These will do, but the JBC tips are just so good. Like, there are no comparison, but a single JBC tip can cost as much as this whole soldering iron. Like, for example, I can show you this knife tip. This knife tip from JBC original cost 50 bucks. And I think this soldering iron isn't even 50 bucks. We will have a look at the listing also. But we will be using the included tips for now. This is a canonical tip, I think it's called. And we have some more. We have knife tips. We have even sharper. We have bent ones. Yeah, we will be using those. The carry case is really nice. And the carrying case also, what does this include? It even has some solder in it. Interesting. This is copper silver based. SN and CU. Yeah. Has some solder in it. I won't be using that because we will be using leaded solder. Let's see, what do we have here? Oh, this doubles as a stand. That is very fancy. So you can just put the soldering iron in here and also clean your tip here. That is very cool. So we can actually use this thing as a station like that. That is cool. Okay. Yeah. Let's just then now use this thing and try it out, how it feels. Let's see for the interface if we plug this in. Let's get this off of here. So plugging it in. Pressing OK. And 350 degrees. It just goes up, DC 20 volts, that is good. Let's see, I already solder, oh yeah, it's just like that, you can go higher. I solder with around 380, 350. Let's see, is there a... Okay, I don't think there's any options. And reacts really fast, it heats up well. That is really good. I'm very interested how this works. If you... So it's in standby. If you hit OK, it then heats up. There are profiles as far as I can tell. Just don't know how to cycle them yet. Ah, that's how you cycle. Just pressing the OK button. Good to know. So we will go 380 degrees. And we will be using this thing now. It very, very nicely plugs into there. So let's go under the microscope and then try to clean those pads a little bit, just using the soldering iron, and prepare the places where we will need some new components. So let's get some leaded solder into here. That I want to say, the tests that I'm doing is with leaded solder. So that, just so you know. So let's see. So this is, I think, just a soldering bridge. Yeah, this is just a soldering bridge. There should be components here probably. And there was probably a component there as well. Let's get rid of this capacitor also, because this is also broken. And let's clean the remains of the coil here off. This is a heavy ground plane, so this will, well, not a ground plane, but this is a power plane. Let's see if we can remove whatever is left of that coil on there. Are those remains of the coil there? Not too sure if there's like part of the coil still on there. Let's see, we probably need more heat for that. Let's go for 420. Yeah, no, I don't think there's anything left from the coil here, because the solder is very molten here. Yeah, no. Okay, that's very nice. So let's go get some flux also onto there, so we can separate those two pads. And we have one more place right here at this place, where we need to clean up the pads from there and here. Okay, let's get the temperature a little bit lower. We don't need 420 for something like that, because the flux burns up so quickly if you do that. Oh, this has a standby mode also, I think, doesn't it? As soon as you plug it into the base. That is very cool. Okay, so we have prepared the places where we want to put new components in. So let's now then go into the board view and see what we are actually missing. And for that we need, for MSI, we need this right here. MS7C91 version 2.3. That is what is important for us in order to know what board view we need, because MSI always labels them like that. So now in the board view, let's have a look. So it was this area. This is the VPP phase, like I thought. So we need an inductor here. And let's see. We need, oh, this is bad, an 887K resistor. Okay, that is not so nice. As you can see, 887K. That is capacitor 0.22 microfarad, 16 volts. We have this resistor is not there. We have this capacitor 22 microfarad, 6.3 volts also. This is the one that was knocked off. This is a solder bridge that is there. 1k ohm resistor, 500 ohm resistor, 309 ohms. Okay. 1 microfarad, 6.3 volts, 220 picofarads, 50 volts. Okay. So this will be interesting. Let's see also for this chip right here. So we're missing this one, 2.2k ohm. That is nothing special. This one is not fitted, and this one is not fitted. Okay. So we're only missing this resistor here, right here, 2.2k ohm. Let's start here then, probably. Let's put a single 2.2k ohm resistor, and then we will continue with this. So there's our resistor. We have a 2.2k ohm, as you can see right there, 2.2. And this one is going to be in the left slot right there. And I do it like I always do. We're going to be taking the soldering iron, and we will be first soldering it on with the soldering iron, just that we have at least one side connected. And then we take the hot air to make sure that it is properly reflowed into place. So we wait until we can give the resistor a nudge, and it goes into place. I should have put leaded solder on the top. I did not. I did do that. Yeah, there should be leaded solder on there. Okay. There it is. Can you see? It's now moving. And now it's properly reflowed. Okay, one place down. Let's move further now to this one. Okay, so we don't have as many missing components as I remembered. So luckily that one is there, but this one will be the biggest problem. This is an 887k ohm resistor. So yeah, that will be interesting. The other one should be easy. I think there's a 1k missing, and then there's a capacitor there. So let me have a look in my stash what I can find. So now we have a 1k ohm resistor, and the 1k ohm resistor belongs to the bottom pad right there. Right there. Right there. Oh. Okay, that will be fine. It is somehow attached. We will do the rest with hot air. So now the next one would be 499 ohms. I only have 470 ohms. So let's see then. Then we're going to put 470 ohms into here and see if that will be a problem or not. Yep, now it's in there. And now I will have to go for a hunt for that 877k resistor. I will have to see if I can find anything similar. I might need to go to donor boards and see on them. So give me a quick moment and I will be figuring out if I can find anything. So I have taken a look at many different boards that I have, and I was not able to find a 887k ohm resistor. And what we are going to do now is we are going to combining two resistors. I've done this before. Take a 68k ohm and take a 820k ohm, and these will go to 888k ohm, and which will be quite close to what we need. So we will be bodging this in now, and I want a tip that is a little bit smaller for that, and we will be trying out the next tip then, and we will see how well we can manage to do that with this soldering iron, with having no experience with this exact soldering iron. So sadly we don't have too much space here, but we will somehow manage. So we have the first resistor right here. What we want to do, we want to get it to the harder place to reach. So we're going to be attaching it to the upper place right there. So let's see now. Let's get a little bit of time for the soldering iron to heat up. And you can see I've taken a smaller tip now. So now we have one resistor attached. And now we're going to be taking the next resistor. So we attach the 68k ohm ones first. And let's now continue with the 820k. There's the resistor that we need. Sorry for the glossy mess. My camera really picks up, my microscope really picks up the glare, sadly. But I think we will be fine. So now we want this to attach to the bottom right there. Just like that. And now we're going to bridge the other end of these two resistors. So that's a little bit too much. Yeah, like that is better. Yeah, like that. So the small tip is precise. It doesn't transfer as much heat, obviously, because it's a small tip. But yeah, the precision is okay. So now we have to check with our multimeter that we actually get resistances like we want them to. So we want 887k between that point and that point right there. Let's see, there's a lot of flux here. And that is definitely not what we want. 360k. Okay, wait, how much do we have from here to here? So this is supposed to read 820k, but it's reading something completely different. Are these my probes that are reading weirdly? Let's see, from here to here. And from there to there. Yeah, my multimeter is reading really weird values here. Let me see if these are the probes that I'm using. I went to different probes and I don't know how much I can trust them. Let me take some different probes and see. Yeah, this reads more like I would expect it to. This now goes closer to the 820k ohm range that we would want. And going from that to there, this should be 68k, yeah. Which it goes. And let's see. The combined value of these two. Let's clean the area up a little bit in order to get a good view of what we're doing here. So let's take some solder off of that big pad. I don't think the tip will manage because this is a small tip and this is a big plane. Ah, even for a small tip this can do it. Take some time. Okay. Now we are cleaned up more. Now we should be able to properly see that these resistors are, how are they connected. So this should be this pad as well. And we should be reading 820k ohms, but it's reading so weirdly. Why is it? Yeah, we don't get anything in that range. I don't really trust my multimeter right here, to be honest. It's behaving very weirdly. Let's see, from there to there, I would expect like 68k ohms. And from here to here, that is so weird. I need, but checking these resistors individually, that is so weird how they're behaving. Are they touching here is the problem. Let's go into that place, take a little bit of solder off of them, because the readings are really weird. I don't know currently if it's my multimeter that is behaving weirdly or if it's actually bad soldering here. Let me figure this out. I will be taking off some solder off of this upper pad here. Like that. And now things shouldn't be touching anymore. So now we should definitely not have a connection between any unwanted places. So let's see once more. From here to here. Now we have good connection, finally. So there was something wrong with my soldering. Now we can see 820k ohms basically. And going from there to there, we now see 68k almost. And now going from there to there, 887k almost. Great. So let's see with my other probes again, just to verify that it wasn't a probe problem, but it was a soldering problem for me, that I made the one blob a little bit too big. So let's see now. From there to there. Yeah, these probes have higher resistance, probably because this probe has seen better days. Let me change out that probe tip. So with a clean new tip, let's see here now. 820. Okay, it was the tip that was making problems. And going from there to there, we have it reads 70. Okay, that is fine. And going from there to there. So these tips or these probes definitely read higher readings than my other ones that I trust more. But now we can see 880k 8k ohms. This is what we want. So that is fine now. We will have to be careful while trying to solder on the big coil here, that we do it on an off angle probably a little bit, that we don't touch these. And we still have to get these resistors into place. So let's get some flux onto these and put hot air them into their places. And try to not knock off our 887k ohm resistor that we have produced. We are currently at 400 degrees, which is a little bit low, which is why it's taking so long, but it will be fine. So let's get a little bit more flux into here once more and raise the temperature just a little bit so I can reflow those two properly. Let's go like, we're going 440 degrees. There we are, and we can see both of them are moving. Yep, both are in place like they should be. So we have our resistors where we need them. And now I will be just taking some random coil off of a different board and will be putting it on there. The coils doesn't matter too much. It does matter, but it doesn't matter too much which coil you take. So let me take one off of a donor board. So now there's a coil here. Let's now see that we can a little bit offset this coil. And what I've also done is I have taken a big knife tip here. Let's see if it's maybe even too big. Okay, let's see. Yeah, I really haven't made this easy on myself with where I place those resistors. That might be fine, but it probably isn't. Let me tinker with this a little bit. So the biggest problem here is the coil is bigger than the original coil that was on here. I don't have a coil in that size, I think. Let me see if I can find one in the proper size. Oh, so I sadly do not have coils that are smaller than this one. This board seems to be using some very weird small ones that I do not have on any of my donor boards, even other MSI boards. So, yeah, this will take some time until I will be able to get that in. I think we're going to do it completely different because we already are bodging here. We are going to make it the following way. What we are going to do is we are going to be attaching one side to here, to right there. And then we will be running a wire from there to there in order to connect this, because the problem is that this big coil won't fit into there. So what we're going to do, let's take some flux, get some enameled wire into here. Right there, enamel wire is attached. And then we're going to be leading it to here. And let's connect some. Let's connect it here with some leaded solder. Like that. And I really got to say that that big knife tip is really powerful. Like, it is huge, but it is also quite powerful. I didn't expect that. Because, like, the pads for these coils are quite heavy with their copper plane, but this knife tip does very well with that. So let's push it a little bit further in, just like that. That's a little bit closer to that. So obviously this is a botch job, like just like with the resistors. But this should work for our VPP. I don't think that we will need that capacitor, because this is just a filter capacitor. We do have our resistors all here that we need, and we put also that one resistor in there. So let me now clean up this area, and then we will either have a look if we're going for passive power consumption already, or if we want to have a look around if there's anything else broken, if there's anything else knocked off here. But let me first do a good cleaning here. So now we have everything attached. You can see the coil attached there and the wire here. We have these two resistors. We have these two that we placed. I don't think we might need this capacitor, but we will try without it first. And yeah, let's have a quick look, I would say, if there's anything more knocked off here. But I don't think there will be. I just want at the edges of the board where it's most common to have knocked off components. But this looks all fine. And close to the area where we were before. And we will probably also have to remove the M.2 cover, because under there's very often damage as well. And then let's look at the M.2. And around the BIOS chip and the M.2, everything looks fine. Let's look at the TPM, the TPM header here, but it looks also to be fine. And let's have a look at the SIO area and above that, because there's often damage through plugging in big GPUs. But this looks fine. No damage around the SIO area, which is very often the case. And let's have a look around the USB and the power, the header, because as you can see, this one is bent, but the rest of it looks fine here. All looks good. That is very nice. Okay, well done. I think it's time to plug this thing in and see how it behaves and see if our VPP is running. So let's go into the overview again. So there's very little space on my desk, because I'm not used to having two soldering iron stations here, even though the one is more portable. But let's get it out of here for now. It has served very well until now. Let's see if we will need it again. But for now, we want to build this board up now. And want to see if we have any reaction or how far this board is getting. Let's go with the 2200G, if this supports it. Because B550 sometimes doesn't support like older generations. But I think it will be fun. So let's get a stick of DDR4 also into here. Next up, let's get a DDR postcode tester into here. Let's see now. We want a TPM. We want a TPM connection right here. And let's see. I cannot plug that into there. Okay. This will be a job for this one here. Yeah, I cannot get into there. There's a TPM header where I like to connect these ones, but the heatsink is in our way, so we won't be able to do that in this case. So no PCIe postcard here. We for now won't go with the DDR4 voltage testers. We will do that later. Let's get now the power then into here. So I think we have a power button and speaker. Yeah, let's do that as well. So, power switch and there. So let's see then now for the passive power consumption. So for the passive power consumption, we want to see around, let's say 120 milliamps, somewhere in that area. So you can either look there or look there. So let's see, pushing the power button. Oh, that is a lot. That was 300 milliamps of power consumption. That was too much. So have a look again. 152, 300 milliamps instantly. That is too much. There might be something shorted here. Interestingly, it starts off with like 120 and then goes to that. Let's see if it has a reaction to the power button still. No reaction to the power button. So we have too high power consumption. So we need to inject voltage into the 5VSB and see for its resistance also. Because there's something starting up that is taking too much amps. So let's see here. Yeah, it has lower resistance. It's not that low resistance. It's going... It's only 3K. Yeah, it really doesn't seem to be that much of... that low of a resistance. But we will have to inject 5 volts. And see how many amps it will take. Because there's something wrong. There shouldn't be that high of a power draw. And we also don't have a reaction to the power button. So something isn't doing what it's supposed to do. Let's take tweezers. And I have 5 volts now on my tweezers. And let's inject that. So let's see. With 5 volts into the 5VSB, we have 650 milliamps. That is way too much. But it has the same behavior of first taking less and then taking more. So I will need the thermal camera and we will need to see what is getting hot. Because that is not the right behavior that we have here. So we have the thermal camera out. And let me now see. There's something getting hot there. So this is the 3VSB regulator right here getting hot. So it's probably something related to the 3VSB regulator on its output side. That is the problem. We have had something like that before. So let's then go to the 3VSB regulator under the microscope and see from there. So this is the 3VSB regulator of this board. And how this works is that we have a input right here, I believe. This is the 5VSB or the 5 volt dual, one of which. And then we have this as an output right there. This is the 3VSB. And we have 1K ohm as a resistance. Interesting. So, yet again, let's go for voltage injection. We this time going to be taking 3.3 volts and we are going to be injecting it and seeing if that is our problem. So I'm going to be injecting 3.3 volts and that is taking 150 milliamps. And I need my thermal camera again. We might also want to check 5-volt dual if that how the resistance of the 5-volt dual is. But first, let's inject the 3 VSB. But I cannot see any heat spot. There's a little bit of a heat spot right there, which is the Ethernet controller. But nothing else to be seen. I want to go back to injecting the 5 VSB and want to have a look at that again, because the 3 VSB really has a very low power draw, like 150 milliamps at 3.3 volts is just nothing. So I want to go with the 5 volts at 650 milliamps again. And if I see anything, if I get anywhere, I will get you back into here. So currently I'm probing our 5-volt dual. And it seems like our 5-volt dual is kinda low with 4.8 volts. It seems to be that that is affected. And I do get a little bit of heat into the PCH, but I'm not too sure if that is our actual problem. So let's look at the 5-volt dual then, if the 5-volt dual has a problem. So the 5-volt dual is actually created right here at the edge. Right here with this MOSFET, and there's a driver also for it. And what we're actually getting are those 4.8 volts. So I want to see for the resistance there of the 5-volt dual. So the 5-volt dual resistance is high also. This is really hard to say what is taking this voltage. Yeah, the resistance is high there. So I will be trying to inject voltage into the 5-volt dual next and see if I can get anything conclusive out of there. So I get the exact same power draw, 670 milliamps at 5-volt dual. So the regulator for the PCH is getting a little bit hot. It's hard to see, it's in the bottom left, but it's getting a little bit hot as soon as we supply that. And you can see also the regulator at the top left heating up a little bit. So I want to remove this coil right here. Let me go get you under the microscope so you can properly see, because I want to know what is actually taking that much voltage. And this is the creation of 5-volt dual right here, this MOSFET and that driver up there. And this is the area that seems to be drawing a lot of current. And this is the choke that you could see here, the top right one. This one is where the 5-volt dual gets in and then goes into this controller and that controller to create the 2.5 volts for the PCH. And I want to know if that big power draw is from the PCH or not. So we want to isolate the 2.5 volts in order to see if that is our culprit of taking too much amperage. So having our soldering iron in here again, and let's now try to get solder on both of the sides of this thing and right there. And let's now go to the side here, see if we can get enough heat into it to remove it with this big tip. Okay, it seems like we're not getting enough heat transfer in order to take this off. We definitely have both joints wet. Kinda asking myself how it can be that we're not able to take this off now, even though there should be way more than enough heat transfer. Well then, we're going to hot air it off then. Just quickly take the hot air. Now that it has leaded solder on there, it should remove quite easily. Why is this so hard to remove? Even the hot air struggles with this. So, now our power supply is isolated. Let's go into the overview. Now I'm interested in how well this will react now. And if we still get that increased power draw when we will be having 5 volts into here. So let's go again for this here. And let's see if we have increased power consumption. No, we do not have any more. That is very interesting to see. And we do now have a reaction to the power button. And we obviously get a CPU LED because we are missing the 2.5 volts that should be at the PCH. But let's first have a look if our voltage is running for our VPP, if that has worked. So the board is on now. Let's see now. We get 2.57 volts. That is very good. So we have now 5 volts for the VPP. And what I want to do now, we now going to be taking our voltage injection again. Let's turn it off for now. And we are going to be injecting the 5 volts at the other side of that inductor. So it's definitely this side of the inductor that took too much voltage, or to draw too many amps, and pulled our 5 volts down. And I want to supply 5 volts now into that place where we have separated it. And I want to see how this board will react. So 2.5 volts in there now. And now we have a reaction to the power button. And now we actually get postcodes. That is very interesting. You see the power consumption 4 amps for a short second, 4.2. And I think our board is posting. So let's get a heatsink onto there, and also a let's also get, where is it? My HDMI cable, in order to see if we can actually get a post screen out of this. So the post screen should be there now. Let's try this again. So have a good look at the power consumption. There's also debug LEDs at the top here, but we will be mostly going over with the power consumption. So pressing the power button, 2.3 amps, 2.2, 2.7, 2.8, 4 amps. Are we still stuck on a CPU LED? No, we are not. It is cycling. And there's a picture at the top right that you could see. It's now booting. So there's nothing wrong with this board anymore. We seem to have fixed it. But why does this only work when externally putting in the voltage? I'm not too sure, to be honest. How does that happen? Because all we did was to move that that choke out of the way for the 5 volts, for the 5 volts dual here, and then inject it ourselves. Not too sure how that happens, to be honest. Is that choke high resistance? Because that choke should be as close to 0 as possible. Yeah, it is. And there's nothing knocked off here, right? All of the parts look fine here. So let's solder that thing back there. I want to see if we get the same reaction again. If we now solder it back into place, and if we then get no reaction to the power button again, because obviously everything seems to be fine with this board, because you just now saw it booting. Like, there's no short circuit why it should be shutting down or something like that. So let's see if we can get this thing back into its place. So it's back in its place. It's not pretty, but it's back there. And the question is, why is the 5 volt dual shutting down so much? Let's clean it up a little bit first, and cleaning it up will also take out some of the heat that is in there right now. The coil really doesn't look great, but its resistance is still as low as it should be, as we just checked. And the 5 volts dual side is also fine, right? Yeah, there's nothing missing here. So let's check that again. So as soon as we now give voltage onto here, we're probably going to have too much power draw. Yeah, 300 milliamps. And if I now press the power button, oh no, I do have a reaction to the power button. Interesting. It's just delayed. And do we get a new post screen? It looks like it. 4.3 amps, yeah. But I'm not sure. Something about the passive power consumption doesn't seem quite right to me. And there we have it, a new picture. But it's weird. Like, now I shut it off. And now we only have 140 milliamps. Like I would expect it to. Like what it should be. So something around the 2.5 volts is drawing too much amps with the PCH. Something is weird. The PCH gets quite warm. But there should be a heatsink normally on here. So I want to put the heatsink onto here and then test, for example, the USB and similar stuff. Because as soon as we were monitoring it under the thermal camera, we just saw a little bit of heat in the 3.3 volt regulator, which is basically nothing. And when we isolated it, we then saw that this area is drawing more amps. But it seems to be fine. Like, that wasn't like it's not getting to 100 degrees or like 80 degrees or something like that. It was just a little bit higher power draw, which is weird to see, which shouldn't be happening, but it is happening in this case. So let's get the cooler onto here again, and I want to go into Windows and see if the USB ports are working, because this is one of the biggest indicators if the PCH has a problem or not. And also testing the M.2 slots will also show if the PCH has a problem or not. So let me get that built up, get into Windows together, and then have a look. So let's see. We can see the 300 milliamps again. And let's press the power button. We have power consumption. And let's now see that we get into Windows here. And we have still jumping power consumption, which is a great sign of it booting up. And now we have a post screen. And let's go with the defaults and continue. And now we are loading into Windows. So I was really worried about the too high power consumption, but it seems to be fine. Like the 300 milliamps, it is weird, but we were able to route it down to the PCH and the supply of the PCH. And yeah, it seems to work just fine. I'm using the USBs from here. It's now into Windows. Let's check that the Ethernet is working, which is also always a good indicator. And Ethernet is also working. So yeah, I have no reasons to believe that this board isn't fixed then. That we just had those knocked off components. And yeah, and having the sponsor of the soldering iron Fnisi is very nice. I want to quickly, at the end of the video, go over the listing that I have provided. So this is the current listing that I was linked to. And it is quite expensive, 85 euros. But this is basically a full station. Like, this is the kit that we have gotten with the 100 volts, 100 watts charger with the 6 tips included, and with the whole stand with it. You have different versions. You also have the ones with less tips. I would always recommend getting actual JBC tips. For the beginning, these are fine, but JBC tips are just way better. They are out of the league of anything else, but you can definitely manage with these. We have, in this video, only have been using their tips that they are included, and you can definitely work with them, and these are way cheaper. I would suggest, if you have a 100 watts or a 20 volt 5 amp power supply, I would tell you to use that instead, going for the bigger version. If you don't want that, if you want an all-included package, go for this one. And the 50 euros is a very good price for this. For my TS100, I paid, I think, 50 euros also. And that was only the soldering iron with a single tip. This one is the soldering iron with 6 tips, and also the case where there's a solder stand right here, includes some solder, and also the braid here, not the braid, but like where you clean the tip. So for 57 euros, I would actually recommend this. I'm pretty happy for that, especially for a beginner, for an entry point, and have it portable. I really like the set. I would only go for the bigger one if you don't want to use the lab bench power supply always. And I gotta say, this cable that they include feels very premium. There's the version with less tips, with only 3 tips instead of 6 tips. I think I would go instantly for the 6 tips then already, but it is cheaper. And yeah, this is only the toolbox. They have this in order if you want to upgrade, because they've been selling the soldering iron before, and this is just the upgrade for the toolbox. But yeah, so my suggestion is either to go with one of these options, or to go with the bigger one if you where the charger is included, if you don't want to be using your lab bench power supply. So this was quite a massive video where I had to go a lot of back and forth and had to do quite some botch jobs as well. But I hope you still enjoyed the video. Thank you so much for watching. Thank you, Fnirzi, for supporting this channel with tools. And yeah, we won't be doing the second tomahawk in this video because this has gotten quite long. And if anything that you want to take out with this video is do visual inspection. There's so many motherboards out there that have broken components like resistors and similar things. And always remember, if you have special value resistors like we had there, the 878k ohm resistor, you can botch in 2, maybe even 3 resistors into a place like that in order to get the right values that you need. And yeah, thank you very much for watching. This was MainboardMedic. Have a great day. And all of my tools, as always, are linked in the video description. Thank you very much, and goodbye.